Good day, and in this lesson we will solve problems using the most commonly used methods such as the high-low analysis or the high-low method and the least squares regression analysis. In this first example, we will use the high-low method. Airy Hardware Incorporated operates a chain of 4 retail stores. Data on the company's maintenance cost for its store buildings and furnishings are as follows. In this problem, we will use the high-low method to estimate the cost behavior for the firm's maintenance costs. We have 6 months, January, February, March, April, May, June, and its corresponding maintenance cost and sales or the activity levels. First step is we will use the high-low method to estimate and graph the cost behavior for the firm's maintenance cost. In this problem, we are not going to graph, but we are going to estimate the cost behavior by getting the high activity level. So the high activity level for sales is we get the highest value, which is 700,000 pesos, and its low activity level, we will find the lowest value here, and it is 500,000 pesos, and we will get the difference. The difference of these two is 200,000 pesos. For the maintenance cost, we will get the highest, which is 55,000, and the lowest, which is 45,000. We will get the difference. The difference is 10,000 pesos. Next is to compute the variable cost per sales dollar. We have here the formula. Applying the formula is we will get 10,000 pesos divided by 200,000 pesos, which will give us 0.05 as our variable cost per sales dollar. Next, we are going to find the total fixed cost. The total cost formula is total cost is equals to total variable plus total fixed cost. So the missing variable here is the total fixed cost. We know the total cost. The total cost is the total cost at 700,000 pesos of sales, which is 55,000 pesos. Then the total variable cost is the product of the variable cost per sales dollar, 0.05, and the highest activity level, 700,000 pesos. We will subtract total cost to total variable cost, which will give us 20,000 pesos. Now we can express it into equation. The total maintenance cost, therefore, is total fixed cost plus variable cost per unit multiplied by the cost driver activity in sales dollars. So we have total fixed cost as 20,000 pesos plus 0.05, which is our variable cost per sales dollar, multiplied by X, which is the sales in dollars. So this is the high-low method in cost estimating this particular problem. We have here another cost estimation method, which is the least squares regression analysis. And in this problem, Jefferson County Airport handles several daily commuter flights and many private flights. The county budget officer has compiled the following data regarding airport costs and activity over the past years. We have designated the flights as X, our independent variable, and Y, the airport cost, as our dependent variable. Next step is to create additional columns such as X raised to 2 and X multiplied by Y. In this column, which is X squared, we will just raise the data. For example, here 12, we will raise it to 2. 12 raised to 2 is 144. For the second row, we have 10 raised to 2, which will give us 100. And we will do this to the rest of the rows. For xy, which is x multiplied by y, we will just multiply this row to this one. For example, for the first row, 20 times 12 will give us 240. For the second row, we have 19 times 10 will give us 190, and we will do this to the rest of the rows. After which, we will get the total for each columns. Now, we will solve for the intercept and the slope. First is for the intercept. For the numerator, we have a summation of y, which is 233, multiplied by summation of x squared, which is 1573, minus summation of x is 135, multiplied by summation of xy, which is 2658. Next is n, which is 12, multiplied by summation of x squared, which is 1573, minus summation of x, which is 135, multiplied by summation of x again, will give us 135. Solving A, we will get 11.796 in thousands. Next, we will compute for the B, or the slope. For our numerator, we have n is 12 for the 12 months, multiplied by summation of xy, which is 2658, minus summation of x is 135, multiplied by summation of y is 233. For the denominator, we have n is 12, summation of x squared is 1573, minus summation of x is 135, multiplied by again 135. For our B, it will give us 0.677 in hundreds. Now we can create our cost prediction line. Our cost prediction line is y. Fixed cost is 11.796 plus variable cost is 0.677 multiplied by the cost driver x. This ends our lesson, and thank you very much for listening. Keep safe and God bless.